Today's lesson is scientific notation. The learning target is I can write both very large and very small numbers in scientific notation. Purpose of scientific notation is to write very large or very small numbers without all of the extra zeros. Think of a million, for instance. A million has 6 zeros behind it. We can get rid of all of those zeros quite easily using scientific notation. Now, the reason we use scientific notation in chemistry is because atoms are really, really tiny. So because they're so tiny, when we have even small amounts of atoms, for instance, 1 gram of hydrogen, we have quite a large number of atoms. And all of these zeros, they're not considered significant. We also don't want to put all of these in a calculator. Trying to plug all of this into a calculator is just creating a gigantic source of error. If you miss just 1 zero, your entire answer will be off. If you miss a set of 3 zeros, your answer will be off by quite a bit. The calculator doesn't particularly like this number, so that's where scientific notation comes in. So this number right here, the 6.02, is called the coefficient. And in this case, all of these digits are significant. We usually like to only keep significant digits here, but there does come a time where they're not always significant. In my opinion, if they're not significant, they shouldn't be written there. But it is a possibility that you could see it there where they are not significant. When you're trying to find out how many digits here are significant, you just look at the coefficient and you ignore the base and the exponent. This base and exponent is supposed to scoop up all of the insignificant digits. There may be a few insignificants left here, but in our case, our decimal's present. So we start at the 6, the 0, and the 2 also count. This would give us 3 significant figures, even though we have all of these zeros. All these zeros get wrapped up in here and are therefore considered insignificant. Next, we have the base. Scientific notation is done with a 10 for the base, although that's not always the case in other areas of math, possibly science, I'm not sure. You can have a base that is a different number, but scientific notation is 10. And then here we have our exponent. It's called an exponent just like in math. And this exponent tells you the number of times the decimal was moved. It's not, I repeat, it is not for the number of zeros. If you were to count these zeros, which I'm not going to, but I will tell you that there are 7 groups of 3. 7 groups of 3 is 21. 21 is not the same as 23. This 23 takes the decimal. We move 21 places to get from back here to here, and then we go 22, 23. So this number tells us how many times the decimal was moved. Okay. Now, I don't love scientific notation because a lot of people tend to not follow this rule. I 1,000,000,000% believe that in order for it to be correct scientific notation, your coefficient must be between the numbers 1 and 10. 6.02 is between 1 and 10, so this would be proper scientific notation. Technically, if I had made this 60.2 times 10 to the 22nd, mathematically, that will come out to this same correct number, but it's gross. 60.2 is not between 1 and 10. It doesn't allow for any type of uniformity. Keep your coefficients between 1 and 10. You also are going to want to keep as many of the significant digits as you can from the original number. Depending on who you talk to, it's kind of all significant digits must be included. Some people say it's okay to round. I'm one of those people who says it's okay to round. Not everybody will agree with me, though. The whole point of scientific notation is to write fewer zeros, and we want to keep out the ones that are not significant. So you could attempt to memorize these things, when to move the decimal to the left and when to move the decimal to the right, but I don't really love that rule because it gets confusing. What I like to say is that when my exponent is a positive value, it means that the original number had to have been greater than 1. So in this case, I have 5.28 times 10 to the positive 7th. This 7 being positive means that whatever this is, the number is greater than 1. It's going to be written in the place of a really big number. This 7 also tells me that I need to move the decimal 7 times. If I were to take 5.28 and try to make it a number bigger than 5.28, I want to move the decimal 7 times and make this number bigger. My decimal is going to wind up moving to the right 7 times. So I move 1 and 2, and then I need 5 more, and that's where these 5 zeros come from. Oh, I didn't fix it. Dang flabbit. I never say dang flabbit. I'm just saying that because I'm recording a video. This comes out to 52,800 because I have moved the decimal 2 times right here, and then 5 more to total the 7. That gives me the 5 zeros. Okay. Next example is for a small number. Exceptionally small numbers are written in scientific notation, again, to keep out the insignificant zeros. In this case, our exponent would need to have a negative value. When you have a negative exponent like this right here, it means your original number is less than 1. Original number meaning the number in standard notation. Excuse me. So this negative is telling you that 1.97 needs to be made into a number that's smaller than 1, and I'm going to move the decimal 4 times in order to do that. If I want to take this number and make it smaller, my decimal needs to go to the left. So I take this, I move it to the left 4 times. It was over here. Now I'm going to move it 1, 2, 3, 4 places, and then that gives me 0.000197. It's as easy as that. This is, again, one of those skills that you learn it with practice. It just gets easier as you practice it. Now, I didn't talk about negative numbers in scientific notation because that doesn't really come up so much in chemistry. It may come up in physics. I'm not sure. I don't remember. But if I was looking for a negative number, the negative would have been out here in front of the number, okay? This negative on the exponent is telling you that it's a super small number, but a negative here would make this a negative number. So if I had, let's just plug it in here for the sake of plugging it in. If I had a negative here, then that would put a negative here. Do you see that? This negative is connected to this negative. This -4 just tells you that the number is smaller than 1. Good? I don't know why I ask questions because nobody can respond. Okay, so that's all I have for you. It's one of those things you learn with practice.